Sound check. Let's try that again. Sound check. Let's try that again. Sound check. All right, that works. Let's see here. So today we're getting right into it again. When we left off, I was in the middle of implementing static scoped variable declarations, which is a big change. So yeah. Let's see here. Here I was testing whether you could disable operator new and make something no longer allocatable on the heap. Which I mean, there might still be ways to allocate things on the heap even with this in there, but this makes it that much harder. As you can see here. Now, what I could do is let's see, align as is a keyword. How does align as work? Let's see here. Let's look it up here in CPP reference. I'm just curious about something, whether I could make something happen. All right, so I can use it here. like this, and then I can put in and that should work. Let's look up placement new in here. What is the correct syntax for placement new? I don't use it very often, so I don't remember the syntax. Placement new. So new buff T. So I did it almost exactly the way I'm supposed to do it. Yep. And if we look at the example here, it's exactly what I did. Yep. Aha! We're running into a very interesting thing that makes what I just did work to nuke all uses of new. Now what I could do is say this. Let's see here. This is just an aside where I'm looking at this thing involving placement new to see if I can get around my whole so I can do it without placement new. I can do this. That doesn't work. I'd have to. Wow, I would have to jump through some. I would have to jump through some hoops. Just a bit. Hello there, Kessie Jones. I'm currently just playing around with placement new because I'm trying to see if I can get around my disabling of operator new here. So I can do this, and then I can say Because see, I could just put in here. I could just put in return new not doable, but that fails. Right? It fails because I tried to use this deleted function here. And so, yeah. So can I get around this? Because I'm trying to see if, I disabled operator new here. What do I have to do to get around it? And any attempt to call any form of operator new on this runs afoul of the fact that operator new exists as inside of not newable, and so it's going to try and find, as long as the name new exists inside of here, it doesn't matter which version of new it's trying to call. It just goes, oh, I'm trying to call new on this thing, and there's a new here, but I can't find a new of the right version, or the version of new that I found was deleted. Either of those two are the case that it comes across. So now I'm trying to see, well, can I go through all kinds of contortions to do the thing I want to do, even though it's, yeah. So, not newable pointer. Right. Then I do this. And I do this. Will this work? No. So by adding an operator new that's deleted to your class, you can basically disable people from using new in any way to create an instance of your class. So you can't, yes. That's very interesting. You probably shouldn't do that because there are reasons why you might want to use, for example, placement new to create instances of the class. But the fact that you can disable new for a class effectively is a very interesting thing to know. I don't really want to do this, but the idea occurred to me, and then I had to start playing around with it in Compiler Explorer until I saw whether it worked or not. Compiler Explorer, by the way, is a fantastic tool. All right, so back to what I was doing. So I've been building this programming language here. And I'm wanting to add variable declarations to it. I don't know if you're familiar with Backus-Nahr form, BNF syntax for describing things. But BNF is the standard way you describe how languages should be parsed. It's supposed to describe a context-free grammar, which no grammar really is fully context-free. But you can get pretty close, like with describing things using BNF. And BNF is described as a sequence of productions. So you can say a sequence is a statement followed by possibly a sequence. So it's a recursive definition, right? So a sequence is basically a whole big bunch of statements. A statement, 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 right? And then, the optional part, the part here in the braces, just doesn't happen at one point in time, and there you go, you're done. Now a statement is one of several different things. It's either an if statement, or it's a while statement, or it's an assignment, or it's an expression statement, or it's a braced sequence. So basically a block. And it might be worthwhile to have an explicit block here, because I do in fact have a statement list as being a thing. But yes. Then a variable declaration consists of the var keyword followed by an identifier, and these are basically token labels, followed by an equal sign, followed by an expression, followed by a semicolon. So an expression is an expression or an expression followed by a Boolean operator followed by a Boolean term, and so on and so forth. This is how you implement precedence in your language. In this language, the ampersands, double ampersand and double or, which are borrowed from C, these operators are borrowed from C. In Java uses them too. They are the lowest precedence. And then the next highest are the relational operators. And then the next highest above that are plus and minus. And then the next highest above that are multiply and divide. And then the highest precedence is anything in parentheses. Right? And so, have you ever seen productions before? Have you ever seen something in BNF form? So I'm implementing all of this stuff using a recursive descent parser. The basic idea of a recursive descent parser is you sort of try all the possible alternatives available at any given point until you find the one that works. And then you go with that one. Yeah. And so here's all of my things for parsing the various parts of the production and so on and so forth. So now we get down to here. One of the things I made as a change to implement this, identifier used to be a reference to the token. Oh, you've already written a parser by hand. Okay. Did it support static scoped variables? Or, yeah. This one prior to this edition. Oh, neat. So you have more experience with this than I do. That is nifty. Perhaps you can give me some advice. Hello there, Sky. I can only easily see people who are here from Twitch. I can't easily see people who are here from yes, from other places like YouTube. Did you write it basically to get experience in writing parsers because you'd never written one before and you figured, well, what the heck? Anyway, I wrote this, or this identifier used to contain a reference to the token, or a copy of the token, actually. And that was it. And then whenever it was encountered, the token would be looked up in a global table of variables for its value at runtime. And I decided that I wanted scoping. And so now an identifier is a somewhat more complex object. And what it does is it points at and it's a raw pointer. So now I'm not using unique pointer. And yes. When I said most things are referred to by unique pointers, like all the child nodes in general are being referred to by unique pointers. So if we go here for binary operation, AST pointer T is actually a name for a unique pointer. So all the downward ownership is done with unique pointers. And this is an upward pointer. This is pointing at the owning stack frame, right? The owning scope. And the owning scope should be something that's in the, it should have a chain of unique pointers that point down at it. And so this back pointer, being a raw pointer, shouldn't be an issue because this thing should always be deleted before its parent. The thing that it's pointed at gets deleted because of the way the ownership works. But Rust would never let you do it. And it's hugely risky to have a raw pointer in here. And then an var IDX, which is basically an index into a variable table for that scope. I decided that instead of naming my variables, I would just have a table of variables for each scope. And you can see that here. Statement list is basically my scope. And I have var declarations is a vector of strings. Because you should always just start with vector for the most part for your things, because it's probably going to be faster than anything else. And besides that, I needed the indexes. Like the indexes are the whole point of this. The index at which the variable occurs in the vector is part of the data. So that's what I'm doing here for this. And last time I had fixed most everything that referred to an identifier. Except var decl is special here. I changed most things. I added a parse identifier, and the parse identifier first of all, assures that the token that it's currently looking at is an identifier. Otherwise, of course, it's not. Can't parse it as an identifier. And then, if it is an identifier, then it goes through a stack of scopes in reverse order. So the most recent, the innermost scope first, and tries to look the variable up in each of them. And the first one it finds, it goes, oh, I found my variable, and then it records the index that it found it at, and it records the scope that it found it in here, and then it finishes. Otherwise, it continues on and continues on, and if it gets to the end, it errors out, can't find the identifier, says it can't parse an identifier here, and fails. I don't know that I should do this. Usually if it's calling parse identifier and then it sees something that looks like an identifier and then can't find it, it's more than just I couldn't parse it as an identifier error. It's a different kind of error. It's somebody is referring to an identifier that doesn't exist in the scope error. And so maybe I should change it, but right now it refers parse error. So there may be cases in which the recursive descent parser goes, well, I couldn't parse it as an identifier. Maybe I should parse it as something else. Anyway, parse factor here should actually. So I added to-dos to remind myself what I needed to do. This change is simple, so I'll change this. One of the frustrations I've had here is JetBrains is kind of annoying. I have, like if you look here, right, I have focus is supposed to follow the mouse, right? You can see that I didn't have to click on this window and bring it to the front in order for it to have focus. Right? Focus is supposed to follow the mouse, but JetBrains is too stupid. And even if I click on the window, JetBrains is like, but you didn't bring me to the front. I wasn't in the back, and you brought me to the front, so clearly I can't have focus. It refuses to accept focus sometimes, and it's just kind of annoying. I like focus follows my mouse. I have objections to VS Code for a few different reasons. Microsoft plugs it way, way too hard, and the way they plug it annoys me. They send women who are not actually involved in the development of, and always women, different women all over the place that are not actually involved in the development of VS Code, but who are developers. It's very clear from when they talk that they are, in fact, people who are knowledgeable about programming. To go try and get other people to use VS Code. And they send them to conferences. They send them to, like I was in a DevOps meetup once, Coffee Ops in Seattle. They sent the women there. They send them all over the place, basically as marketers. They take these women with significant developer experience, and then they go tell them to run around and flog VS Code. They basically treat them as mascots, right? They treat them as mascots, and I don't like it. And I don't like that they're pushing it so hard. What are they getting out of it? Why do they want to spend all kinds of money sending women all over the place to flog their product? I don't trust it. So maybe VS Codium, I would use that. But then VS Codium can't use half the plugins. So, yeah. Yeah, well, I don't know what I want. I don't want to get addicted to their Copilot API either. I don't want anything to do with something that Microsoft is pushing that hard. Especially when they go out of their way to make it hard for an open source alternative to exist, despite the fact that they have it be open source. They're trying to have all of the market cachet of it being open source, while preventing any actual open sourceness. Yeah, well, I like the JetBrains people. The value proposition here is obvious. I know what they're up to, what they're about. They're based in Eastern Europe. I have a trust for Eastern European countries that aren't, especially if they don't like Russia very much, and they're not too poor. If they're too poor, the thing I get worried about with Eastern European countries is maybe it's malware. Otherwise, I like stuff from that part of the world, and I have a fair amount of trust for it. Anyway, I'm here to try and parse this as an identifier. So, not see here. No, what I want to do is parse identifier, and then like that. That should work. Hey, I have a simple parse identifier. Yeah, right here. Parse identifier. What are you talking about? No such symbol exists. It does too exist. In fact, I define it right down there. Grrr. Okay. It doesn't know what it is either. Well. If it is an ID, then we return. Actually, we don't have to do that. We can just return just like that. Parse result t is a pair We'll do it this way. The new form of the if statement. There we go. Like that. Okay. Now, does this compile? Yes, simple evaluator is going to have to radically change here. So what we're going to do here is just going to say there we go. That's a good catch here. Simple if it has we are just going to say again current result and hello there. Welcome to the channel. I'm not quite sure how to pronounce your name. Working on building a parser. Oh, yes. And right now I'm trying to get things to compile. And I'm mostly just chopping code out that doesn't work and putting a to-do in here about having to fix it. Because I'm just trying to get it all to compile, and I'm in the process of ripping my code apart and putting it back together again. And I want to check whether something is correct. In order to get it to check if it's correct, I have to make it compile, and yes. These are not the parts that I want to check if they're correct, because they are incorrect. They need to be fixed in sometime in the near future. And then so next. Oh, now that's going to be interesting. Here's what we're going to do here. This will work. And no, it's not id.name. It'll be id.vardex, like that. No, that's right there. Variable, not even knowing its own name, has to go look it up in the scope in which it was declared. Let's see here. Welcome back, Kisi. As I said, I'm process of fixing some stuff. This is going to have to be if zeroed out. Because I don't know that assignment statement has been properly modified to point an identifier. Oh, no, it has been. Actually, so I don't have to fix this. I can, in fact, do this. There we go. More places where things need to be mucked with. Oh. There. That was dumb. So, going through here, basically I'm letting my compiler do the work for me. Var decal. Oh my. This is the right thing to do. This is the right thing to do. Now, identifier is technically supposed to be an AST node, but I'm putting the identifier in here directly as a thing instead of a pointer to its node, which is fine. Identifier, in fact, is copyable and movable. And so we don't need it to be an AST node in either the var decal or the assignment statement. But it does need to be an AST node everywhere else because it's indistinguishable from something like a numeric literal. And so we'll just deal with it being here. And then here, we'll, instead of putting ed.identifier, we'll do like that. There, I use for AI. Go back and look at the code that I've already written, because it couldn't have written this code itself. It tried and it got it wrong, but now, once I've written it, it's smart enough to realize, oh yes, that's what I'm supposed to do here. Well, yes, it doesn't have a name. Oh, here. Yes. Um, and then here, there. And I'm just letting the compiler find the next error for me and then fixing it as I find it. It's the easiest thing to do with handling something like this. And then here, there. Okay. And no, we don't want indeed vardecal just needs to do this to no, because it's not done yet. I want to test whether this other thing compiles correctly. And in order to test it, all right then. Yes, I have not yet changed this to use parse identifier. So, all right. So what's this about parse identifier not existing? Oh, what a stupid mistake. All of that because I made that mistake and the compiler was getting all confused and not knowing what the type of grrr. And yes, you should be able to do that actually. You should be able to initialize a pair from a... Okay. There. That should work just fine. What is your problem now? Oh. We will do it this way, adding another level of indentation, which I don't like. But and that means all of this has to be re-indented. And I need to add an extra close brace here. Oh, you know something? It doesn't need an else because there's a return statement. Okay. Silly me. So I can just do this. There. That should work. There we go. Okay. Now why I couldn't just decompose the parse result and then recompose it again? Because I have this brace initializer thing all over the place here, right? Why did it not work there? I don't know. But regardless, oh, I needed to move it. I needed to move on the ID part of it. I see. And this works without move because it's actually a return value optimization. The return value optimization means that this isn't even a move operation. It's just a nothing. So that's good. Any questions, Cody C. Wiseman? Now let's look for my to-dos. Not going to fix that one right now. I'm going to fix that one. I think there's actually an explicit tool for changing this. Okay. This one we will change. But we're going to do the assignment statement first. Do you know why the one parameter had to be a move when I was trying to do the brace initialized return value before? Sky? Eat cheese, is that the reason why? I mean, I don't think that eating cheese is bad advice. This is also done in a repeated nesting style that I think is bad. So I'm going to go through and change that as I fix this. The reason why is because parse result t has as an AST pointer as its first thing. And an AST pointer is a unique pointer. And so unique pointers can't be copied. They can only be moved. That's the reason why the brace initializer list wasn't working, is because the first parameter needed to be something, have a std move in front of it. That's why. Let's see here. How long is this line? Go down here, 80 columns, just barely. Okay. So basically, if we failed to parse the very first thing as an identifier, then we go, nope, couldn't, this is not an assignment statement. Okay. Ooh. There's a problem here. This needs to be outside the loop, or outside the if statement. So, check. Parse an identifier is the next thing. Did we succeed? No. Did we? And now we go here for ID result. Now we actually care. Okay. Auto ID, comma, after ID equals parse identifier, blah, blah, blah. And then if not ID, then we weren't looking at an assignment statement. If the first thing we saw could be parsed as an identifier, and it's not an assignment statement that we're looking at. Now, if after ID equals finish. So if the next token, if there's no tokens after this, then okay. Now we double check if not so if the next thing is not if the next thing isn't an equal sign, so basically if it's not, like we're looking at the next token, first, is it an operator? Okay, we know it's an operator. Well, if we look at it as an operator, is it the right operator? Is it operator equal? That's our, and here, we're going to do this. Yeah, we'll just do it like this. Still too long. I'm not going to worry about formatting for this right now. I have some strict rules about formatting, so. Consequences of capitalism, as if capitalism is some kind of evil. Capitalism is the only system that has actually consistently functioned correctly. All the other systems have resulted in mass death and authoritarianism. And nobody should tell you that, oh, but it wasn't real, whatever it was. It was exactly real, whatever it was. Now, let's see here. Yes. Well, yes. The consequences of unique ownership. I will agree with that. And it is funny. Just people making jokes like that often. It's a funny joke regardless. I'm just kind of triggered by the fact that there are a lot of people who make jokes like that because they think capitalism is bad and that we should be doing something else, but they don't ever have any idea what else would actually work. And oddly, capitalism is a name for what we have that I don't think is wholly accurate. I prefer the term free markets. Free markets are good. And without a free market system, Yeah. And capitalism has become synonymous with free market systems for most people, but I don't know that that's necessarily the right way to think about it. Anyway, regardless, it was a funny joke. The expr remainder parse expression. So now no, here we get to, because clearly, since there was no equal, we're not looking at identifier. Okay, now we can go if, and then we can go if after equals finish, and clearly we're not looking at an assignment statement because there's nothing after the equal sign. Otherwise, let's try parsing whatever it was as an expression. If it's not an expression, then clearly it's not an assignment statement. Now what I could do here is I could print out this error message, because once we get here and we discover that it's not an assignment statement, something weird is going on. And that's kind of putting the error, like technically, what I should be doing is passing around more context back about the failure so that a better diagnostic can be deduced at a higher level. But right now, I'm reduced to this. This is basically kind of special casing it into the recursive descent parser in a way that we probably shouldn't in a pure implementation of a recursive descent parser. So, if remainder not equal to finish, and standard holds alternative, if the remainder is not equal to finish. Okay. So we already know we weren't able to find I will do something repetitive here. And also to remainder. No, not. Yes, exactly. That is what we want. So basically, two possible cases of, and what I could do here is I could complicate this thing and I could go like this. And if I do that, I should do that. And I should do this. There. There. Short circuit evaluation means that we'll never try to evaluate star remainder if remainder is finish. And so we're good here. Okay. But otherwise, everything's great. And here, we don't want to make unique AST node. What we want to make unique AST node with is like this. No. Hey, What are you doing trying to re-indent absolutely everything when I tell you this? No, no, no. That's not what I told you to do. Stop that. What did you do to my code? What the heck? Okay, it's because there's something wrong with parse expression, with parse if else. There's something wrong here that's causing this everything else to fail, which is fine. And this is correct. This is correct. And this is no. And all of this stuff is pointless. No, we don't want any of that. Okay, now it all goes back to being good. Okay, now we don't want the ID token here. What we want here is just to make a good old copy of oh, yeah. Assert that we actually are looking at an identifier. First, if we get here, we already know ID actually does contain a value because we noped out if it didn't. So we know that we can do star here. Assert holds alternative star ID. So we're basically asserting we demand that ID have we assume that ID has an identifier here. And now here, what we do is yep, like that. Oh, no, that belongs there still. Yes. Okay. Now, why does it think that there's a whole big... Oh, because I had this return statement at the beginning. There. All right. Basically, we copy out the identifier. I should make scope. One of the things I should do with most of these things are already not copyable. Statement list is already not copyable because it contains a vector of statements. It already is movable. I should make statement list not movable though. Most of these should be not movable. Yeah, I'll deal with that later. The reason why they shouldn't be movable is because there's a whole big bunch of things that have pointers to them, and it matters that they have pointers to them. Statement list in particular will have raw pointers to it, and so it very much shouldn't be movable. Yeah. So I'm going to do this. Yep, can't be copied, can't be moved. Oh. Because the statement list can't be moved. So I can't put statement list in here as a thing. I'll deal with that at some other point in time. That is a silly example. That is a silly example. I'm not sure what to do about it. So we'll leave this here. Basically, what it's saying is I'm trying to make an when I'm trying to make the statement list AST node, while I construct an empty statement list and move from the empty statement list into my brand new statement list that I'm making with new here. Which I need to do in order for AST node to be tagged as containing a statement list. I'm not quite sure how to create an empty I don't know how to do the thing I want to do right offhand without enabling this one particular case of an empty statement list, which is harmless, being moved. But in general, statement lists shouldn't be able to be moved. And I don't know from all of those other things here whether that's the case or not. But it's neither here nor there. Not going to worry about it. Just going to allow a statement list to be moved, even though if it is moved, that breaks things. Okay. Now that we have parse assignment statement working, let's get to parse var_decal. Now, parse var_decal is a lot more interesting because parse var_decal has to not use the parse identifier, because parse identifier, part of what it does is it looks up the identifier in the table, right? We go down, let's go down here and actually look at parse identifier, right? So if we look at parse identifier, which is down here at the end, parse identifier does all this actually looking the identifier up in my stack of scopes. So it looks it up in the table, and when it doesn't find it in the table, it's a problem. But var_decal is ideally the identifier shouldn't be in the table. If it is in the table, that's a problem. That's not true. If it's in the table for the current scope, that's a problem. Because you're declaring the variable twice. But that remains that, in fact, it's not a problem if it's nowhere. If there's no table that contains the identifier, that's in fact not a problem for a variable declaration, because, of course, this is where you're declaring a brand new variable. So here, we'll look for the var keyword. Then if we find it, then start can equal finish. Okay. We'll go to the next thing after it. And if we are at the end already, then we're done. So then we look at the next thing. And here, we need it to actually look for the token identifier. We can't just parse identifier because of the reasons that I just gave. And so Now we found our identifier token. Now, so let's actually go through this. We'll do all of the parsing first, and then we'll do the table stuff. So then we're going to look to find out if we have an operator. Then we're going to find out if we have an expression. Then, now that we know everything's hunky-dory, we have an expression, we have an operator. Oh, the next thing, and we have a semicolon. Right. So we have the result. Okay, that is exactly the right thing to do. The last thing on the block stack, and here we're going to do this. Assert. We're asserting here that the block stack can't be empty by the time we see a vardecal, right? That our stack of blocks, which we push something onto the stack at the very beginning for the global block. So the stack of blocks can't be empty. So now, we look at the last thing on that stack. We look at its vardecals, except we can't. First, we have to do this. There. Okay, so we need to look through. So block decals should be a vector of string. Oh. I have to use. So we search blockdecals.end. This probably doesn't work, right? Find if needs a predicate. Let's look for the find if in CPP reference. Let's see if there's one that actually takes a value. So we have find. Oh, we do have a version of find that takes a value. Yeah, we have one that takes a value. Sirens. I'm turning off the sound for a bit. So there is indeed a version of find that takes just a plain old value. Yeah. So we don't need find if. We can just use standard find. And this should be fine. blockdecals.begin, blockdecals.end. And without the annotations, what column are we at? It's still 86. Okay. Now we're at column 71. Good. Okay, that should work. So if it's not equal to end, and it was smart enough to know what the problem was. Well, there we go. And no. That's not what we're looking for. Block decals. Yes. And here, block decals, place back, value. Now we return. And here we aren't making an assignment statement. We're making a var decal. And oh, we are making an identifier. That's actually right. We should have an identifier here. And here we need a make unique AST node. We need an identifier and ctx dot no. There we go. Comma. Standard move expression, indeed. And So comma, the next thing would be no. Okay, so here we're making a vardecal. Vardecals consist of an identifier and an expression. An identifier consists of the scope and the index. Okay, so here we're making the identifier. Here we're making the expression for the vardecal. Here we need the remainder. And then this is the end of the make unique. And this is the end of this. I see, yes. There we go. Okay, why does this one not like this? Oh, the reason why is because, in fact, we're not putting an identifier there. We're putting in, or not putting an AST node there. We're putting an identifier there. This does not contain an AST pointer. This contains an actual identifier. So here we're just going to initialize the identifier with the appropriate stuff. Okay, that is the right thing to do here. Need a semicolon there. Okay. Let's see if this compiles now. All right. So that's right. Now, let's go back through our other to-dos. Yes, there we go. To do, fix this. All right. I think I'm at an ending point for this stream now. The hard work is done, and now it's mostly filling in some details. There's actually tying the static scopes and implementing them as the program is running, which is important. And it would be really nice to be able to test this change without testing whether the programs run or not. But I'm not quite sure how to do that. I don't know that I think all of my tests tend to execute things after they're parsed. I don't think I have things that actually test the parse independently of running them. Yes. Which is a mistake. I should have had tests that didn't actually try to run the program. So, yeah. And the tests that would test the parse, of course, are all going to fail because adding variable declarations and the insistence on variable declarations drastically changes the way any program that uses variables works. Yeah. So I don't. All of those tests will need to be redone. They should all fail. Any test that currently involves assigning something to an identifier will fail now. Anyway, as I said, I think that's it for this stream. So that's that. I hope that you all have a good night, and it's nice seeing you here, Cody. I hope it was educational. Do you have any questions? I guess not. So